Okay, proving trig ratios and then verifying trig ratios. Let's see what we can do here. Sine squared x plus cosine squared x plus 1, and they just want us to end up with a single trig ratio rather than a couple here. I can think of a couple of ways to crack this one. First, sine over cosine is tangent. So sine squared over cosine squared is tangent squared x plus 1. Technically, that's already a single trig ratio, but we could make it even simpler if you notice there's a Pythagorean identity which says that 1 plus tan squared x is secant squared x. So both of these contain only one trig ratio, but this one is even simpler. Here's an alternate way to solve that one, just in case you want to see something different. Sine squared x over cosine squared x plus, I'm going to try to get a common denominator for both of these. So this is over cosine squared x. I'm going to write 1 as cosine squared x over cosine squared x. Now we can combine those and we get sine squared x plus cosine squared x all over cosine squared x. Sine squared plus cosine squared is 1. So now we just have 1 over cosine squared x. The sine squared plus cosine squared is the first Pythagorean identity. And if you memorize an identity, this should be the one. We use this quite a bit. And 1 over cosine squared, you'll recall, is exactly what secant means. So again, we end up with secant squared x. That's two reasonable ways to attack this one, and of course they both come out to the same answer. Let's see what we can do down here. Sine x plus cotan x cosine x. I don't instantly have any ideas for this one. What I'm going to try, something that very often helps is, if you have a bunch of different trig expressions, try to turn them all into sines and cosines. That increases your chances of being able to combine or cancel things. So this is already a sine. I'll leave that alone. Plus cotangent. Regular tan is sine over cosine, so cotangent is cosine over sine. And then we have cosine x. That didn't help a heck of a lot, did it? We can combine these two and get cosine x, or cosine squared x, sorry. I'm not sure if that will do anything for us. I think what I'll try next, I'm going to combine these two to make cosine squared, just to keep things neat. I'm going to put both of these over a common denominator. So, multiply the top and the bottom by sine here, and we get sine squared x. Now I see what's going to happen. Sine squared x over sine x plus, and then we have cosine squared x over sine x. Combine those and you get sine squared x plus cosine squared x, which is just 1 over sine x. Or, if you prefer, cosecant x. So, two problems, and already the Pythagorean theorem has helped us twice. This is a great identity. I urge you to commit it to memory. It wants to be your friend.